Good evening everyone. Welcome to another session of DevSpace webinar series. This would be the second webinar out of 5 webinars that would be covering on the way to TED 2015. We hope we all enjoyed last week's webinar on tab application development with Node.js. So today we will be discussing and demonstrating IoT APIs. IoT APIs are the newest addition to Zenit Mobile's API family. So to give you an outline on what we would be covering in today's webinar, first, we will be discussing on what is IoT in a nutshell and IoT with Zenit Mobile APIs. Then, how a business could be transformed by IoT, which will be followed by a demonstration and a coding session. Last but not least, Martin from Ubuntu would be connecting from UK to cover how IoT innovations are done via Ubuntu Snappy. Alright, by now you might have heard the term IoT a lot, I guess. This is one of the quotes I found. IoT is an evolution of mobile, home and embedded systems that are connected to the internet, integrating greater compute capabilities and using data analytics to extract meaningful information. So, billions of devices will be connected to the internet. As related devices get connected with each other, they can become an intelligent system of systems. Remember, system of systems is key to IoT, where there is no human interaction in the process. Once the size and intelligence of the systems grow, they can transform our businesses, lives, and our world in countless ways. So, my co-presenter JK will explain Zenit Mobile IoT APIs.
Hey guys, let me start with a small introduction on how Zenit Mobile is stepping into M2M and Internet of Things. Since you're watching this webinar, I hope you guys have a bit of interest in M2M and IoT stuff, and yes, it's all emerging fields and several people are trying to define it in several ways and trying to implement it in different and effective mechanisms. On the other hand, if you take Zenit Mobile Tab platform, as you already know, it opens up many APIs for developers to play around with telecommunication core network, such as messaging APIs, charging APIs, and Android in-app APIs. Now it's time for Zenit Mobile to introduce its IoT API. So what is Zenit Mobile's IoT API? Simply, our IoT API enables a developer to program his device to talk with other devices and make a network. Before going to details of implementation, I'm sure now you have a lot of questions how the IoT infrastructure works and what Zenit Mobile's Telco API is going to do with that. And why do I have to choose Zenit Mobile IoT for my business? When we talk about Internet of Things, it's important to realize that there is an ecosystem which has existed a long time and should adapt to meet new challenges. The idea is we have devices running applications which connects over a network through a platform. And there is a lot of challenges emerging. How can I uniquely address a device on a public network? How can I track a device not being in a house but moving on a road? How to reliably deliver commands and notifications to a power-constrained devices? And of course, questions like where is my security? How much time do I have to wait? So we have been working on addressing each of these issues from Zenit Mobile to build the next IoT API. The first influence Zenit Mobile has on this ecosystem is the network. Zenit Mobile APIs runs on top of telecommunication core network, which is the fastest and most secure network covers the whole world. And in Zenit Mobile APIs, we have invented the cheapest ways to communicate over telco network. Say that what you just want to do next is to plug in your device and call Zenit Mobile IoT APIs.
Before plugging in your device and calling IoT APIs, let me brief you all on how a business can be transformed using IoT. Remember the coffee shop example we've been developing throughout? Now the coffee shop group is expanding their business. The group has coffee vending machines located in multiple locations to serve the public, like a central city supermarket, hospitals, and everywhere. But the group goes through a tedious process in maintaining those vending machines. On a daily basis, a guy personally visits each vending machine to check and refill the needed. But with Zenit Mobile IoT APIs, this business process is transformed to a new level. We fix a sensor to each vending machine. Sensor continuously checks the status of each coffee type and notifies the coffee shop head office's supply chain management system. The supply chain management system creates the coffee distribution report for each day. So the next day, consider the notifications it got from each vending machine. It would deliver the coffee. With this, the process of managing the vending machines got a lot more streamlined. Over to you, Sandarenu and JK, to demonstrate the technical aspects.
For the demonstration of the vending machine with the ingredient level sensor, we have created a simple setup with a LED and a LDR. Here, when the ingredient levels goes down, light of the LED will be detected by the LDR, and we use that reading to say ingredients are running low. Our setup has a Arduino Uno with a GSM shield. Here I have plugged the GSM shield to the Arduino Uno. Then we have a LDR coupled with the 10K resistor as a voltage divider, and I have plugged the data of the LDR to the A0 of the Uno, and then we have a LED with the 330 ohms resistor. So that's the setup we have. Now our circuit is ready. You can see the complete circuit diagram in this slide. Let's connect the Arduino to the PC to load the Zenith Mobile IoT kit. JK will explain you how to load the IoT kit to the Arduino using Arduino IDE.
Okay, so I think now you're excited to make something like this, and the question many of us has now is, do I need to learn how to program in Arduino? The answer is no. Why? We have Zenith Mobile APIs that make developers' life simple and bring everything on your hand. So what you just need to do is buy an Arduino and GSM and make a base circuit like this and load the Zenith Mobile IoT kit into Arduino. Let me show you what is Zenith Mobile IoT kit and how to load it in this Arduino. So we have published this IoT kit into Zenith Mobile's GitHub page. You can go to GitHub and type Zenith Mobile and search. There you can see Zenith Mobile's IoT kit project. So this is the program which is going to run inside the Arduino board. Just download this one, and once you download it, you can go to downloads and see that IoT kit master is downloaded. There's a zip file, extract that, and in this IoT kit master you can see these readme files and license, and there's an IoT library IoT directory. Just open up, and there is a configuration file. Open that in your favorite editor, and there you have to configure your application code and SIM number. So these things you have to get while provisioning your IoT application with Zenith Mobile APIs. So once you configure this, just save these things, and now you have to load this program into Arduino board. So for that you need to have Arduino IDE. You can download Arduino IDE from Arduino website, and I have downloaded here. So the thing is, you have to open the file in IoT kit master which we have downloaded. In library IoT, there is a library iot.ini file. Just double click that, and the Arduino editor will open that. And now I have connected the Arduino through USB. So you have to check whether in tools you have to check in board is selected. My one is Arduino Uno, and the port also should be Arduino Uno. Make sure you have selected those things, and there is an upload button in this Arduino editor. Just click on that and it will compile your code and upload into Arduino board. Yes, done uploading, success. So that's all you have to do with this device side. So let me show you how to do the programming side of your application, which is going to talk with your device. We are going to write a simple JavaScript application with Node.js to connect with our device. So we will use a WebSocket to open a connection with our device, and then we will send and receive messages. So I have created an empty project. Let me create a JavaScript file called myapp.js, And to do this WebSocket, I'm going to use Node dependency. I hope you have a bit of understanding on how to use Node and Node application and Node dependencies from the previous webinar. So let's go to this Node repository and search for WS. So that's the WebSocket dependency for Node. There you can see how to install this dependency. npm install ws. Simply copy this and run this through your terminal. Sudo npm install, and that will install WebSocket dependency, and that's all. So after that, you can see a simple sample application how to use WebSocket with this dependency. So here we can create a WebSocket to a specific address, and then we can send and receive messages. So let's copy this code snippet to my app, and the place where we are going to connect is Zenit Mobile's IoT platform. So here's the URL, and this is the token that you have to get while you are provisioning your IoT application. So let's copy and paste that thing. So this access token will identify your device inside the Zenit Mobile's IoT platform. So now we have created a WebSocket, and let's see while it's connecting, just print something, say connected, and once it's connected you can send and receive messages. So here also we can say console log, and you will receive the data from the device. So you can just print the data and see how these things work. So to run this application, you have to configure Node.js plugin. I have already installed, and you have to say this is the file I'm going to run with Node.js, and then you can just run it. Now your application is connected with IoT platform, and now I'm going to boot my device. The coffee vending machine setup we have done. So now when the device boots, it tries to register with our IdeaMart network and search whether someone is trying to connect this device. So now we are connecting through this WebSocket. So the device will send a boot command to our application. So now here we got this boot command. So you can see what is coming here. It sends a timestamp, an ID, and a content, and a type. So the type is a boot, and it will send a device address to us. So now we have connected and send the command, and we received the command from the devices. So now what we have to do is we have to do something useful with the device, right? So now what we can do is, now if the command is boot, then the device is ready. Now we have to tell some instruction to that device, right? So when the ingredient level goes down, send us a notification. So let's see how we can do that, right? So now we are getting the data. So the data is a JSON. So first let's try to get this message. JSON pass and get the data as a message, right? Now if the message is a boot one, message dot type equal to boot, then this is the first time the device is connecting. So we have to send the instruction, we have to send a command to that device. So how we can do that? So you can go to this WS, the WebSocket library, and see how we can send WebSocket things. It's simply ws.send. So we can send this like ws.send, right? So what we have to send is a JSON again. So JSON.stringify, I will use JSON.stringify. So the parameters are again like ID. So we have to send an ID and a type of the message and the command, sorry, the content and the device. So what are these things? So the device is simply the address of the device where you have to send a message. So the device address we are getting from the boot. So we can simply get it from this message.device, and the ID is something you can give to refer it back, and the type is now we are going to command the device, mmand. So what is the command? So this command is actually we are using this bitlash library. So the bitlash is a programmable command shell. You can go to bitlash.net and see the documentation how you can send command to a Arduino device. So you can have commands, functions and stuff. So that's the format you have to send. So for example, we will write a simple thing like what is our purpose is forever the device should check for a port where the ingredient level is measured, and if the ingredient goes down it has to send the reading of the port, right? So I will write while 1 it has to execute, right? And what it has to execute, if the port we are listening for the ingredient level, that is the A0, is less than our threshold is 200, then it has to send us back the reading, right? So that is print, and let's say it will append a string with the reading of A0 port, and since it's inside a while loop, we have to make sure we just put the snooze 1 second. So it will wait for the 1 second and do this thing again, right? So let us stop this and try to run this. And I'm booting the device, and also I'm going to show the serial port output of the device. Actually you don't have to do that, just showing you what is happening inside the device. So now the device is trying to connect the network and register itself, and it sends the boot message. Now once we receive this boot message, we will send the command and it will receive the command and it start executing. And now let me simulate this sugar level going down stuff. Yes, now it's detected that the sensors are detecting that sugar level, the ingredient level is going down, and it will send me the notification back. So you can see in our application terminal we will get the notification saying level is 138. Okay, now I know you are excited to try this out, but before that you can now listen to Martin, VP of IoT from Ubuntu, explaining on how IoT innovations are done with Ubuntu Snappy.
Hi, my name is Martin Ictus. I'm the VP of Internet of Things at Canonical. You might know Canonical for its product Ubuntu, which powers most of the public clouds. Some months ago, we launched Snappy Ubuntu Core. Snappy Ubuntu Core comes from a lightweight version of Ubuntu called Ubuntu Core that is stripped of all unnecessary features. And through doing that, it can run on smaller boards like, for instance, the Raspberry Pi, BeagleBone, or others. What we also did is we took from our Ubuntu Phone team the capabilities to put apps on top of Ubuntu Core and run them in a secure containment. This means that even if somebody writes a bad app or a badly written app, it should not impact the other apps or the base operating system. Ubuntu Core is also transactionally upgradable. And the last thing is probably the most important things for developers, is that it has the capability of app stores. So what does this all mean? Well, it basically means it's the first open source operating system that can put apps on any smart device. Smart device can be anything. Think about anything that runs Linux nowadays. You probably can count about 10 or more devices in every home or business or whatever. And now think about what changed between the first mobile phones. So think about the Nokia phones and the latest Android or iPhones. You see that like apps have revolutionized the world. Now what Snappy Ubuntu Core brings is the same capability of running apps on top of smart devices, but you're no longer limited to only phones. So if Uber can stop all taxi drivers in the world and make global strikes possible, think about what the capabilities are as a developer if you now make apps for any smart device, for drones, for robots, for set-top boxes, for network equipment, smart hubs, alarm controllers, anything that you can imagine. You just have to go and get a Raspberry Pi 2, a BeagleBone Black, or any of the other devices that support Ubuntu Core, and you can immediately start making apps for it. Now, everybody, when they think home automation, they think IoT, they all think about like what is possible on like 4G networks and the latest and greatest. But with this video, I would like to challenge you to think out of the box. What is possible if the latest and greatest isn't available? If you don't have 4G, but you still want to have like a networked application, what can you do with 2G? What can you do with USSD? What can you do with SMSs? What can you do with lower end hardware? And this is exactly where I think HSenid is hitting the nail on the head, because their platform allows developers to use globally available solutions, not solutions that are available in only some of the cities in this world. So if you're a developer and you are working on the latest tuk-tuk taximeter, or you want to make anything automated around people's businesses, communication solutions, anything like that, please check out Snappy Ubuntu Core. You can go to ubuntu.com/things and you can see how you can very easily create snappy apps. So the way Snappy works is there's a base kernel that is different based on the hardware family. So you'll find different ones for Raspberry, then from Intel, and so on. Then you find a blob which is Ubuntu Core. Since it's dynamically or transactionally upgradable, we allow 2 blobs to be deployed, one for the current version, one for the new version, and this is all automated inside Snappy. And then on top, you can have 2 types of things. You can have frameworks. Frameworks are trusted applications that get more privileges and as such can do certain things that other apps cannot. The idea here is that if you would have, for instance, some networking hardware acceleration and only one app at a time can do something with it, then you can make a framework that mediates, and as such multiple apps can use it at the same time, and it's the framework that gets access to it. So this is why we have frameworks. And then snappy apps are very easy to do. You just put all the executables that you need for your application plus everything they depend upon in one directory. You put a meta directory with a YAML file, and you find all the examples as well as the right syntax on ubuntu.com/snappy. You put that there, you describe which things we need to execute, which ports to open, if there's a specific app armor profile, and so on. And then by doing snappy build and pointing to your directory, everything in that directory will be put into a tarball. That tarball will be called .snap, and this can then be uploaded into the Snap Store. Or if you have a development machine that is available that has the developer mode enabled, so there's two versions. One can have like developer mode enabled, and what you can do there is use Snappy Remote to directly inject your app into that running machine. Or the other one is sort of like production ready. In this case, you can only download apps that come through the Snap Store. So as a developer, you don't actually need specialized hardware. If you have an old laptop available, you can also use that, or a desktop, you can also use that and convert it into an Ubuntu Core machine by using some USB key and booting Snappy up. And if not, you can get any Raspberry Pi 2, not the previous generations. You can have Odroids, you can have BeagleBones, you can have Udus, Banana Pis. There's a long list of boards that are available, as well as open source platforms that you can use on top. So think about open source things like Device Hive, Car Project. There's also things that connect into the cloud. Think about Cumulosity. And there's lots more. If you take a look at ubuntu.com/things, you'll find all the current partners we're working with and all the solutions they have available to you. What also is interesting is that Snappy Ubuntu Core also runs on the cloud, so you can boot it up on Azure, on Amazon, on the Google Cloud, and on other clouds, and then also use it as a minimum operating system for Docker development. So whatever you want to do, be it revolutionizing some single small device out there and controlling somebody's home, somebody's business or whatever, or if you want the other extreme and put it on the biggest clouds in the world, Snappy Ubuntu Core is your solution. And I am very, very interested to see what ideas you can come up with, how you can make complex things easy, how you can software define complete new devices. And just as a last remark, just an example of what we did on one of the biggest telecom events in the world. We bought the cheapest Intel server with 6 ports. We put Ubuntu Core on it, and then we started putting apps on it. So we put an app that created a switch. So the first port became outgoing, the others were local. And then we put like a load balancer, a firewall. We put some monitoring software from Zabbix on it. We put some Microsoft real-time integration into the Azure cloud. We put ARM device management software to IoT framework so that it could control the lights, can get information about temperature, could do scrolling publicity on a connected LED screen, as well as a robotic arm could be controlled with it. So that server, that switch, all of a sudden could become a robot controller, an IoT hub, or anything. And that's the power of Snappy. You can software define everything. You don't longer define what an appliance does when it rolls out of factory. It's just an app away of adding more functionality to it. So I'm very interested what you will come up with this new capabilities. So anybody that comes up with something amazing, let me know, because we are very happy to publish blog posts on our ubuntu.com or insidesubuntu.com to show what the community can do with Snappy. Thank you.
So, we've come to the end of our webinar. Hope it was insightful for you. If you want to get more information on Zenit Mobile APIs, and webinars, visit our site devspace.zenithmobile.com. As I mentioned at the beginning, this webinar series leads you to our next big event happening on 13th and 14th of June, the International Telco Application Development Hackathon, which is happening around the world. With all the other exciting events and activities, you will be coding your idea from 13th to 14th June while brushing up your pictures. Your applications would be evaluated by a judging panel where the winners would get exciting prizes. So, stay tuned with devspace.zenithmobile.com for more details. Looking forward to see you guys at the next webinar on tap application development with WebRTC. And thank you.